have already seen that pseudocode can be documented using three important constructs, namely sequence, selection, and iteration. We have already seen sequence, which is execution of steps one after another. Most of the time, a sequence will follow an input, process, and then output stage. But selection in any given program allows us to follow two different program paths based on a certain condition or decision. As such, selection is also about decision making in your program. When you want to make a certain decision in your program, you can use the selection construct. So the learning objectives of this lesson is to explain what is meant by selection, write programming statements that involve selection. Now, these are the three control structures, like I've said: sequence, selection, and iteration. Selection decides which statements are to be executed depending upon the result of a given condition. And how do we create condition as such? We have seen in the previous lesson. We can use the comparison or relational operators joined by some Boolean operators. The relational operators can be greater, less, or equal, not equal, and so on, where we can compare two given values. And Boolean operators are used to join two different conditions. Now let's see how you can use selection using if statement. We'll have to write down the statement: if, then test a condition. If this condition evaluates to yes, as I've said, this condition is made using some relational operators, which is comparing two variables or a variable with value. Then it will execute this statement here. As such, when this condition evaluates true, this statement here will be executed. If this condition gives us an answer yes, the block of statement here will be executed. Now see, we have the if keyword, then the condition, and then. Sometimes you may wish to put the then on other line, but it's better to use other line for indentation purposes. And see here, I indent my statement by leaving a space. This makes the program more readable as such. Let's see an example. Let's say you're inputting a given mark for a test, and you want to output whether the student has passed or failed. The first line is we input the mark. As you can see, mark is a variable here. Now, like I said, when we say input mark, what happens during this statement is that the user is going to use the keyboard and then is going to input a value or key in a value through the keyboard, and this will be stored in the memory location mark. So diagrammatically, we have memory location mark somewhere here. Okay, a memory location mark somewhere here that is expecting a value. And let's say on my keyboard here, I input the value 40. Alright, now this is a memory location for mark, therefore 40 will be stored here. Now, as you know, program, when it jumps from one line to another, it doesn't remember, it has to look back into memory location. So input mark, I input a value for my keyboard here, which is 40, it gets stored to the memory location for mark. Next, on the second line, I ask, is mark greater and equal to 40 using the relational operator. Now, the program will ask itself, so what is the current value of mark? So we look into memory, it's 40 now. Now, is 40 greater or equal to 40? Yes. Since this condition here has evaluated to yes, therefore I will evaluate this program statement here, which is pass. Therefore the program is going to output pass. Now, for this given program pseudocode, we have only one option, which is output the statement pass. If the mark is less than 40, it's not going to output anything. So let's see. The mark is 40. We input mark 40, again stored in memory location 40, it output pass. Now, let's say for a second mark 30. Is 30 greater or equal to 40? The answer is no. In that case, the statement here will not be executed. Therefore, no output is produced. Now, we know that we want to output fail as such with only one if statement. It gives only one possibility as such. Sometimes we want two possibilities. If this is a no, do something else. And for that, we need the if and else statement. So same for 45, it's going to output pass. Now let's take a look to an evaluated version, let's say not really, an improved version of the previous example, but here I've set the pass mark to 50. Now as you can see, now we have two possibilities. Either we output pass or fail. Remember, print is the same as output. You can use either print or output. So I input a mark. Let's say I'm testing 60 first, and in the memory location marks I have the value 60. So I'm going to ask a question: is 60 greater than or equal to 50? Yes, therefore it's going to print pass. Now let's look at a second value, 45. Now I input mark, the value is 45 now, and if 45 is greater or equal to 50, the answer is no. Now since it is no, automatically it's not going to execute this statement, it's going to execute the statement at the else part. Now this is known as an if and else statement. It gives rise to two possibilities in the program. And see, the else part doesn't have any condition. If this condition fails here, automatically the else part, the body of the else part, is executed. So this is very important. The else part doesn't have any condition as such. If statement include a condition, if the condition fails there, the else part will be executed. So as such, you can see we have taken a decision based on whether marks is above and equal 50 or it is less than 50, which output then fail. Now there are several types of selection statement, and selection actually decide which statements are to be executed depending upon the result of a condition. So you need to be able to write clear condition, for which we're going to see in a few minutes when we study selection even more. For selection, if following statements are used, we have the if else, we have also some kind of nested if statement, and also we have the case statement, which we're going to see after practicing few exercises on if and else statement. Now, if statements are used when there are one or two options. When there is only one option, as you have seen, we can just use simply an if statement. Without an else clause, it is written as follows. We have if given condition, then if the statement is true here, it's going to execute the statement. Now here you can see we are doing comparison of a given number with the largest number that we have just seen. So if you look at the condition here, it is if number is greater than largest, then execute this part here. When there are two options if statement, with an else part is written as follows. If this condition is true, this statement here will be executed, else this statement here will be executed. Like I said, if mark is greater or equal to 50, we can just assign. Here we are assigning the result, and based on that result we are printing it here. So it's simple. We have a result variable. If mark is greater or equal to 50, we are assigning it to pass, otherwise we are assigning it to fail, and then we are outputting the result fail in the end. Now let's look at the first evaluation for you to understand the concept of if statement. So how do we work out this example? So if you take a look, we have three memory locations here. We have A, we have B. Now A is first line, A is assigned to 3. So memory location A will have the value 3. Remember, assignment means that we change the value at a given memory location. B is 5. Now A is equal to B plus 1. So we know that B is 5. Now we take 5 plus 1, which is 6. Now A is going to be overridden by the value 6. Therefore we cut 3 here. We put the value 6 to that particular memory location. Now we begin the condition. If A is greater than B, now if you take a look, 6 is greater than 5, so therefore I have evaluated currently the condition as yes. Now since this is a yes here, or we can say it is true, this statement here will be executed. If this was false or no, this is going to be executed. Now if we see A is equal to A multiplied by 2, in this case the value of 6 will be multiplied by 2 and reassigned to A. So 6 times 2 we're going to get a value 12. Now what is the current value of A? Therefore as such it will be 12. Now assuming that we are inputting two values A and B, and as you can see in this question, if A is 5, B is 3, it asks us what is the final value of A and B. Now like I said, when we input a value for a variable, we have two memory locations reserved for them, A and B, like you can see on the screen here. These two memory locations, when I say input A and B, the user is going to type a value on keyboard. As such, A is currently 5, B is currently 3. Now we begin the if statement here, if A is greater than B. So another way of saying it, is A greater than B right now? Yes, because A is 5, B is 3. So here it's yes. If it is yes, it jumps here. If it is no, it jumps here. Now A is equal to A times A. Therefore I'm going to take the value 5, which is here, and multiply it by itself. So for 5, as such, 5 multiplied by 5 will be 25. Now 5 multiplied by 5, you can see that multiplication as an operator is represented by an asterisk and not an x, which is multiplied here. So 5 multiplied by 5, this is 25. So what is the final value of A and B? So A will be 25. You can see that A has been squared. A times A is squaring of a given number. Otherwise, if it was a no here, B would have been squared. Therefore, final value of A is 25, and that of B remains unchanged, which is 3. Now, let's look at an evaluation quickly. Input a number and output if it is positive or negative. So for this, I'm going to write it and explain you how we are going to do this. So first we need to input a number, and then we're going to check whether it is positive or negative. So if you look at it in terms of a number line, we are going to assume that for now that 0 is. So in this example, we're going to assume that any number greater than equals 0 is positive. Now you can see we already have, it's just an assumption for now. We know that 0 is neutral, but later on we're going to improve this particular version of program using a nested if statement. But for now, if it is greater or equal to 0, it's positive, and anything that fails this condition greater or equal to 0 is going to be negative. Let's see how you're going to write. Now, as you know, if condition function as follows. We have if a given condition, then, like I've said, it's better to put then on the next line. Then we're going to output some kind of program statements. Now, there is two possibilities. Either it is positive or negative. Therefore, I will need to use if and else statement because it can be either positive or negative. Now, this is the skeleton of, like we say, skeleton, the structure of writing an if and else statement. Now, we need to input a number. So, we know how to input a number. Here, we are not focusing on declaring the number using some particular data type. But remember here, let's assume it's integer. Now, we input the number here. The number is a variable. Now, you're going to see, I'm going to write my first condition. First and only condition is this program. Now, we know that any number greater or equal to 0 will be positive. As such, I'll write down if the number is greater and equals 0, right? I use a variable and I compare it with a value for which it can be either positive or negative. If it is greater or equal to 0, I have first of all an output of positive, otherwise I have an output for negative. So either positive or negative. Now let's say the number is 5. So in the memory location number we'll have a value 5. It comes on the next line. Is 5 greater or equal to 0? The answer is obviously yes here. Since it gives us yes, we're going to execute this particular statement of the line. Okay, which is positive. Now, if number here is minus 5, let's take a look what happened next. Now, is a number greater or equal to 0? Now, if you're looking at the number line, minus 5 is not greater or equal to 0. It's obviously less than 0. In this case, it's going to give us negative. So this is how you write down statements or programming statements involving the if and else statement. And it's very important because as we move on through our programming principle, we'll be studying more complex example where we need to integrate if statement inside a for loop or a while loop or a repeat until loop. So that's one example. Let's take a look to a second example. Input a number and output if it is even or odd. Now, I'd like to introduce one particular operator here, which is known as a mode operator. Okay, the mode operator, before jumping to this example. The mode operator, which we will study later on in any given session afterward, where we have complex example where we have to find out even or odd. But for now, just a small review. When I do 6 mode 2, in this case, what it means, 6 mode 2. The mode operator functions by taking this number, 6, and divide it by 2 and find out its remainder. So in other words, we take 6, we divide it by 2, and we note down what is the remainder. Now we know that when 6 is being divided by 2, in this case the remainder is 0. Now 7 mode 2 in this case will give us 1, because 7 divided by 2 gives us a value 3 and a remainder 1. Now you can take a look to another odd number, 13 mode 2. Again, the remainder is going to be 1 because it's going to divide 12, which gives us 6, and remainder is going to be 1. Now if you take a look, all even numbers, when we apply a mode of 2, it gives us a remainder of 0. Same for 12, you can see mode 2, it will give us 0. Remember, mode is about finding the remainder. So all number, when we apply a mode of 2, it's going to give us either a remainder of 1 or a remainder of 0. If it gives us a remainder of 0, it means it is even, otherwise it is obviously odd. Now we know that we need to input a number and see if it is even or odd. Let's jump how we're going to let's jump to the next slide and see how you're going to write this statement. So first of all, we need to input a number, and we write down input number. So for now I'm going to choose num. Now if that particular number mode 2, I can just write down mode in capitalize if you want. Now if I apply a mode 2 and this is equal to 0, then on next sign, remember your indentation, there should be space in between here. Let me escalate that. Then we output even. Now you can do the reverse. If it gives us a remainder greater than 0, you know that it is odd, or give us a remainder of 1, then it is odd. Here I'm going to put F as capitalize. Else we output odd. And if now let us understand how this program is actually working by adding a table. We will study about this table later on as dry running. For now, let's see a simple example. Now let's say the number I'm inputting here is 6, 12, 0 also. But yeah, let's assume that I'm not going to input 0. Otherwise we'll need what is known as validation of the word, which you're going to study. And let me change that to 15 because 15 is an odd number. And this one to 11, and I'm going to delete that particular row here. Now if you see the number and then the output, let's see. If I input the number, the first number is 6. Now I ask myself, is 6 mode 2? If you compute 6 mode 2 somewhere here, okay, let me see, 6 mode 2, we know that 6 is exactly divisible by 2, so it will give a remainder of 0. Now if this statement here gives us a value of 0, we're going to output even, otherwise we're going to output odd. In this case it gives us an output of even, therefore I write down even. Now 11, when I input 11 mode 2, it's not going to be 0 obviously. In this case we're going to output odd. Now same for 15, when it is divisible by 2, it's going to give us a remainder of 1, therefore it's going to output odd. This is normally how you write down programming statement, especially the if and else statement. Thanks for watching. If you like this video, click like and subscribe. Thanks for watching.